Say for example, I just need to tell somebody that go east only, go east only, go north only. Okay, so in that case I just need to give the direction only, na, sense of direction, not the magnitude. So for that I just need a symbol which just represents sense of direction, and that is the unit vector. And for x-axis, positive x-axis, we use I cap. For positive axis we use j cap. For positive z-axis we use k cap. So cap over the vectors, over the symbol. Cap is the symbol for unit vector, and you can see that the magnitude of each one of is 1, because if nothing is there, so I can say 1. If I need to represent negative x-axis, negative I cap, negative downwards is negative j cap, and negative k cap. So there are these 6 unit vectors. I need actually basically fundamentally 3 only. I need to represent direction. Okay, so that is the resolution of a vector, and unit vector is plays very important role in that as well. I'll tell you how does resolution of vector and these unit vectors are linked, but first let's focus over the unit vectors more. Say for example, I say there is a vector a, 2i cap plus 3j cap. So even if you think of it, then it is something like this. Say for example, this is a vector, 2i cap 3j cap, and if I say what would be the unit vector, now the thing is direction is we only tell, na. That mean, do you think there is only 6 direction? Positive x, positive y, negative y, positive z, negative z. There are many directions, infinite directions. So I need unit vectors. I can have unit vectors for each directions. I can have unit vectors for each direction. I repeat. So a vector, the a vector is also having its own direction, and which is this, something like northeast. So if I need unit vector for that, so I would represent a cap. So that is vector divides by its magnitude, just that is. So I just need to divide vector with its magnitude. So what is the vector? 2i cap plus 3j cap. And what is the magnitude of this vector? Magnitude of any vector is, what is the magnitude of any vector? It is actually the length of that vector. So ax square plus ay square. Okay, if I need to find the vector of magnitude of this vector, so that would be 2 square plus 3 square, and that would be nothing but root 13. Let's do more talk over this, but first of all I'll just give you this represent unit vector. This is the unit vector in the direction of a vector, and what is its magnitude? Only 1. It just represents direction. Now let's talk over the same vector, and let's try to combine things. If I say this is a vector, a is this vector, 2i cap plus 3j cap. Actually, what does it represent? It represents there in the x-axis its component is 2, that means its magnitude. In the y-axis, positive axis, its magnitude is 3. So it is actually the resolution of a vector. If I write a vector in unit vector terms, I'm actually resolving it. Okay, I'm actually resolving the vector. Say for example, this is the a vector, so one component of this is, if I say in the x-axis, would be this, would be 2, and one component in the y direction would be 3. So now I don't need angle, anything else. I just need to look what is after I cap, what is before I cap, what is before j cap. So that would be the vertical component of that vector, that would be the horizontal component of the vector, or resolution of a vector, or projection of the vector. So I can say that ax is 2 and ay equivalent to 3. Now if I'm talking about the magnitude of the vector, that's mean the length of the vector. Say for example, there, this was the vector, a vector. So if horizontal component is 2, vertical component is 3, can you find the length of the hypotenuse? Easily. This is a right angle triangle, you can drop a perpendicular. After drawing a perpendicular, the length of the base is 2 and the height is 3. You can easily find the hypotenuse or the length of the vector or the magnitude of the vector. So always the magnitude of a vector would be the under root of the squares of the squares of the various components. Okay, so you get this thing. I can represent any vector. Say for example, I represent a vector in this term, az k cap. So these are the actually I already had resolved it. This is ax, this is ay, this is az. Say for example, there is a vector a and it is represented by 2i cap minus 5j cap plus 15k cap. So if I say what is the ax component is 2, what is the ay component is negative 5, what is the az component is 15. So the thing is, these are the various components. And if I ask what is the magnitude of a vector, so you would square ax square ay square plus az square. And if I ask what is the unit vector in the direction of a, so what do you need to do? Unit vector is vector divided by its magnitude. So it would be like 25 to 25 to 50 to 54 to 54 root. So what was the magnitude? What was the vector? 2i cap minus 5j cap plus 15k cap divided by root 254. So this is the unit vectors in the direction of a vector a. So we have talked about the unit vector. This is enough for the unit vectors. Okay, so no problem with that. I talked for resolution of vectors, and we had talked over unit vectors as well. So resolution of vector is only in the x axis or y axis, or is it in the two perpendicular directions? So don't confuse with the x axis and y axis, because x and y axis are references and we take it. These are not standards. We take x axis and y axis. These are not standards. Okay, say for example, I'll tell you, this is an inclined plane at an angle theta, and there is a mass of m. So what would be the weight? Weight is the force, and the direction would be mg. Direction would be this, downwards, and magnitude would be weight. The magnitude of force or weight is mg. Okay, weight, force, mass is not a vector, but weight is a force, is a vector. So I can resolve it in two directions. One is this, perpendicular to the plane, one is along the plane. Okay, so this is theta, this is 90, this is 90 minus theta, this is again theta, this angle is again theta. So the mg, this component would be mg cos theta along with the theta, and this would be mg sin theta. So I can break it into two perpendicular components actually. So I'm resolving not into x and y typically exactly into x, y axis, as we can take any axis as x axis, any axis as y axis. It is dependent on us. So I always take two perpendicular axes, because this makes it easier to work. Okay, so mg cos theta, mg sin theta. Say for example, you don't worry, these would be very handy things. As the course would proceed, you would feel that these are the easiest things. So if I say this is angle 37 and this is 5 kg mass, So can you resolve it into two perpendicular components? Yes. So what will be the force? 50 Newton, then this, and then this. Force is 50 Newton, then this is 37, this is 53, then this is again 37, then 50 cos 37, 4 by 5, so that would be 40. So this would be 40 and this would be 30, nothing more than that, nothing less than that. So this would be, kind of resolution in inclined plane. Okay, so resolution we have done unit vectors. So mostly we have done everything in this chapter, and let's proceed with another thing in other video, like the product of vectors. Addition, subtraction is being done, everything is being done, and as I told you, if there are more than two vectors, how does the resolution of vector is helpful? Say for example, one vector is, you just need to resolve it. This as I had resolved 2i cap minus 4j cap plus 5k cap, and there is another vector. After resolving, I am writing in terms of the unit vectors, like 10j cap plus 15k cap. So somebody asks you to add these three vectors, vector a plus vector b plus vector c. Nothing, just add the one with the one proceeding with the proceeding the I cap, one proceeding the j cap, one proceeding the k cap. So just add the numbers of them. 4i cap minus plus 9j cap plus 20k cap. This is the answer. And even if you had the diagrams of that, say for example, I give you three vectors. One is this, one is this, and one is this. Okay, so this is like x and y axis, and this vectors makes an angle of say for example 37 degree, and the magnitude is 5, its magnitude is 10, its magnitude is 15. So look, this vector, can I resolve this vector into two parts? Yes. Look, just this vector 5. So this would be its horizontal component would be, say for example, its name is a, its name is b, its name is c. So ax would be a, that's mean 5 cos 37, that is 4 by 5, that is 4, and ay would be, this 3, 5 into sine 37, 3 over 5, so that would be 3. So eventually if I sum up them, so the net, say for example, is r, its horizontal component is 4, its vertical component is 3. So net, the vector which I get, the resultant vector would be in axis is 10 plus 4 14 I cap, and 15 plus 3, that is 18 j cap. Okay, just add then those, because this is I can write a vector as 4 I cap plus 3 j cap. I'll discuss it in length. Okay, I'm discussing it in length. B vector was just 10 I cap, and C vector was, I don't know what is it, 15, and in the vertical direction, positive vertical, the j cap, then it would be j cap. A vector is this. Now I need to add all of the three vectors. So just add the one before the I cap, 10 4 14, and the one before the j cap, 18. Okay, so this was everything which I have done here. You can, at this moment, this might be looking complex to you, but it's very simple, it's very basic. Okay, just revise those things, and then we'll do this in the next video, like the product of